So a trick when integrals are kind of complicated is to use a substitution for the most complicated piece and then try to work it out so that du is the rest of it. So if we let u be x to the third plus 3x squared plus 3x, then du is 3x squared plus 6x plus 3. So we don't quite have that, right? We don't have du. But if we were to multiply the entire top by 3, we would have it, right? Because this would be 3 times 1 is 3, 3 times 2 is 6, 3 times this would be 3x squared. So we want to multiply the entire numerator by 3, but we can't just throw a 3 in there, else it's not the same expression. So we have to balance it out by multiplying the outside by 1/3. So now this is du, and this is u. Now we can make a substitution. Sorry, okay, so I'm not going to put the limits of integration because we've changed the variable. So we got du, this is what the numerator is, and then u is the denominator, or in other words, you could say that's 1 over u du. So we know what the antiderivative of this is. The antiderivative of 1 over x is natural log x, so same thing if it's u. So we've got the antiderivative. It's 1/3 times natural log u, and then our limits of integration. Let's turn it back into x though, so we can put those limits of integration in there. Natural log of x to the third plus 3x squared plus 3x, and then we evaluate that between 1 and 2 according to the original problem. So that's it. Then you just got to plug in 2 and then find out what happens when it plugs in 1. Let me just check and see if WebAssign wants decimals or not. The answer I saw, they want it in terms of a natural logarithm, so I'll finish it out for you. So we're plugging in the limits of integration. If I plug in 2 to the third is 8. This is 8 plus 12 is 20. 20 plus 6 is 26. We need to subtract what happens when we plug in 1. So 1 to the third, so 1 plus 3 is 4, plus 3 is 7. When you subtract two logarithms with the same base, these are both base e, then the arguments can divide. So our final answer, when simplified, is 26, natural log 26 over 7. And then there's still that 1/3.